Hey Math Kids, today we're going to talk about problem solving with quadratics, and your book has a couple suggestions, and so we're going to go through that. So step one, they suggest turning words, turn those into algebra. So basically write an equation or numbers or something, turn the words into a math problem. Okay, step two, solve the equation, so solve. Step three, examine the solutions carefully to see if they are acceptable. So basically, see if answers make sense. And then step four, give your answer in a sentence. So reread what they're asking for, and then answer directly answer the question that they ask. All right, so those are the suggestions of the book. I think they're pretty straightforward and might be how you would have approached it anyway. But this first example says a rectangle has length 3 centimeters longer than its width, and its area is 42 centimeters squared. Find the width of the rectangle. And so I would start by drawing a picture. So we have a rectangle, and it says it has a length 3 centimeters longer than its width. So we have the width, and then we have the width plus 3. And these are given in centimeters. And we know that the area is 42 centimeters squared. Alright, now hopefully you guys remember that the area of a rectangle is length times width. And so if we do W times W plus 3, that should equal 42. So we distribute that, we get W squared plus 3W equals 42. Now that's quadratic. So our quadratic methods generally require us to get everything on the same side. So we end up with this, and we can always fall back on the quadratic formula. I don't think this one will factor, so I think we need to. And so our A is 1, B is 3, C is negative 42. And so we get the opposite of B, plus or minus square root 3 squared minus 4AC. That's all over 2 times A. Okay, watch the quadratic formula video if you need a little refresher on that. But, need to do that. Okay, those together are negative 42. Negative 42 times negative 4 is going to be positive 168. And then plus 9 because of the 3 squared. And if we add those, we get 177. Okay. So we have this. Now, if we tell someone, okay, the width of a rectangle is negative 3 plus or minus square root of 177 over 2, probably just going to punch us or something. So we do need to go to a calculator. And we'll try each one at a time. So I'm going to say negative 3 plus square root 177. And then divide that answer by 2. So that's 5.15. So that's one of our answers that we get algebraically. Now we're going to say negative 3 minus square root of 177. And then divide that answer by 2. We get negative 8.15. Now, keep in mind that these are what we are claiming our width to be. Having a negative width does not make sense, and so we're going to throw that out. And so our answer that we're looking for is going to be this one. Now, we need to write our answer as a sentence, so I'm going to go back through and read the final question. It's not really a question, but it says find the width of the rectangle. So we're just going to say the width of the rectangle is 5.15 centimeters. And then we're done. I think there's just one more example, yeah. It is possible to bend a 12 centimeter length of wire to form the perpendicular sides of a right-angled triangle with area, is it possible, with an area of 20 centimeters. So the situation is this. We bend a wire like this, and then we know that it's making a right triangle like that. But the wire is only the orange portion. Okay, so it's right angle. We know the total length of this, so this plus this, so like x and y, so x plus y equals 12 centimeters. And so the way we're going to do it, we're going to just call this x, and then we know this would be x, or not, sorry, it'd be 12 minus x. Because if we use up some of it, let's say 2 centimeters, then we would say 12 minus 2, and that would get us 10. So hopefully that makes sense. Once again, these are measured in centimeters. And then we know that the area of this is 20 centimeters squared. Okay, so the area of a triangle is 1/2 base times height. We know the area is 20. We know the base is 12 minus x, and we know the height is x. Okay, so we set that into our algebra expression, and I'm going to distribute the x. So I'm going to keep the 1/2 out there, but we get 12x minus x squared. Then we multiply the 1/2 through that, and so we still have our 20. And if we cut 12 in half, we get 6, and then minus 1/2 x squared. Alright, so once again, this is quadratic, so I'm going to get everything onto one side. 0 equals, and I'm going to write it in the order that we generally have quadratics. Okay, so dealing with that fraction, that's not very fun. So I'm actually going to do a couple things. I don't like having a negative out in front here, so I'm going to multiply everything by -2 to clear the fraction and clear the negative. And then I'm also multiplying the 0 by -2. So 0 equals x squared minus 12x plus 40. And maybe I can factor this. Let's try. Let's see. Is it possible? Okay. So if we do it, I don't actually know if this is able to be factored, but let's try. So 140, 220, 410, and 85. Okay, so I guess it's 13. Okay, so that doesn't work. Now, if we plug this into the quadratic formula, we actually might be able to just get away with the discriminant. So let's just try it that way. So remember, that's b squared minus 4ac. And so negative 12 squared minus 4ac, 144, negative 160. So that's going to be a negative number. So we know that we have two complex roots, or it does not cross x-axis. And so even if we went through the whole quadratic formula, we'd get two complex, which has an imaginary part to that. And so that means that this situation is actually impossible. There's no way for it to have an area of that and for these two sides to add up to 12. So we want to answer that as a sentence. So we would say it is impossible because our quadratic solutions were complex. Okay, if you need additional help, please come to Math Lab. Until then, calculator.